Hello, welcome back to parser hacking. We've been working on our recursive descent parser. Let's just kind of review what we've done so far. We did parsing numbers and operators, operator precedence, which is really cool thanks to the parsing technique, which we talked about in one of the videos, and strings, being able to parse multiple expressions separated by new lines and semicolons, assignment, method definition, and more recently we did something that is unique as far as I know to the Ruby parser, which is method calls versus local variable lookup, and that's something the parser handles, so we were able to do that. And in this video I wanted to work on method calls with parentheses and without parentheses, and basically, passing arguments to methods. And this one right here is just a duplicate of up here, so I'll take that out. I'm not going to make videos about the rest, I don't think, unless something comes up as I'm working on it and I realize that it's a unique concept that we haven't really covered. I don't think I'll be making videos about class definitions because it's really a lot like method definitions, not too unique. Module definitions will be similar. Even arrays, it's just matching a token and then looping until we get all of the expressions inside separated by commas. So I don't think there's anything unique there that we haven't already covered. So let's get into the meat of this video and work on method calls with parentheses and without parentheses. And let's just do this one first. So let's just have one failing test here that we can run. Okay, unexpected open parens, and we know exactly where that happens in our parser. Now I did split out off camera. I split out my header file into an implementation CPP file so that I don't have to have a huge header. But in a parse expression, what's happening is the null denotation will pick up the foo, and then it tries to go into this while loop, and it doesn't know what to do. It can't find a left denotation. Sorry, my light is flickering. It's kind of weirding me out. Anyway, can't find a left denotation for the left parens. So I think that we need to do two things. First off, the get precedence, which is in the header for some reason. I left it over there. Get precedence of the L paren. Let me explain. Parser test. What we're going to do is treat this sort of like an operator, this left paren. Even though to our eyes and our sensibilities, this feels like something entirely different, it's really not. It's really sort of like an identifier and then an open parens operator, and then some gobbledygook in the middle, which are going to be arguments like A, B, C. We're not even worried about that right now. So stuff in the middle, potentially, or nothing, and then we're just going to match a closed paren. But this isn't even that important because that's not an operator. That's something we're going to consume and throw away, but it doesn't really mean anything. So the way I like to think about it is it's an identifier, and this left paren is an operator, and then we're going to consume the arguments, and we're going to create an expression out of the whole thing. I hope that makes sense. But once I realized that, it kind of simplified this a whole lot. So method calls with arguments, with parens, that is, method calls with parens, is just another operator with precedence, just like anything else. So we're going to do L paren here, and we're going to say this is the call precedence because, if I can find it, our list of precedence is here. The highest precedence is call. I hope I did that right. We'll find out, right? I mean, we'll find out together. What are you complaining about? Duplicate case equal. Oh, because I already copied that. That's why. Okay, so that's the get precedence side, and then that's going to handle getting the right precedence, and like we went over in our parsing video, it's going to do the right thing, hopefully. If I am processing this right. And then left denotation, we need a new left denotation for L paren. like I said, we're treating it sort of like an operator, but we're going to call this parse call expression. So let's go down here to this one and let's just copy this call expression and let's go to the header. I'll just put this over here on the side. And we'll do this call expression. It has all the same arguments. Oh, I don't think I showed you, but I made an alias. Let me pull this up. I made an alias for this vector of locals called locals vector putter. Just made it a little bit simpler for readability, I think. So that's why that's there. But now, what are we going to do? Well, we're going to advance, and this is something as you know, I forget all the time. Advance past the current token, and which is a paren. And then let's go look at our test one more time. We don't have any arguments yet, and I think we should just do the minimum amount to make this test pass. So we're going to say if the current token is not an R paren, then we're going to raise unexpected. And I have added a little debug here that call R paren prints out when you have the debug flag turned on, that prints out that little string, and that's why that's there. So if it's not an R paren, then we raise an error. Otherwise, we carry on as if everything's fine. And before I forget, I'm going to call advance again to advance past that R paren token, and we're going to return something. New call node. And let's go look at Parser HPP, and let's look at call node and how that is constructed. So it gets a receiver. We need a new node called nil node. It's something to represent a receiver, but we don't really have a receiver in this case. And the receiver would be like if I had foo.bar, the receiver would be the foo. And we're not even doing the dot thing. That'll be another operator that I probably won't even make a video about. But the dot, spoiler alert, the dot will just be treated like another operator, another infix operation. And we'll be able to put this as the receiver. Anyway, all that to say that we need a new node type, and that's in Parser HPP. And let's put this in alphabetical order. Actually, I don't even really need much to it. It's going to do almost nothing. It's going to return, it's going to have a toRuby. It's virtual here. I could probably just I'm tempted to make it inline, but my brain just can't handle that. So I'll never be able to find it later. Let's put this here and say nil node toRuby, nil node toRuby. It just returns nil. Pretty, not a new though. Pretty simple implementation. It's not going to do a whole lot there, but we need that because somewhere, where were we? I've already lost my place. Right here in the call node that we were building earlier, we want the receiver to be a new nil node. And Parser HPP, call node. Okay. And then the second argument is the message, which is going to be a symbol. And it's going to be the left node. It's going to be the name of it because it's an identifier node. And we're going to have to trust that it's an identifier node. That's probably, I'm going to throw an assertion here. Assert left type equals node type identifier, because I don't want this to segfault in some weird way, or I don't know. Just want to be safe. left, and then we're going to call name on that, which returns a string. Okay, so what have I done wrong? No. Oh, not symbol node, symbol value. That's right. Symbol value intern. There we go. Okay, so we don't have any arguments yet, so we don't need to add those. We're just going to return the call node. And parse call expression gets returned from left, left denotation, which gets run right here. I think that might just work. We will find out. Probably forgot to do something. No, actually worked. Sometimes I'm surprised. Sometimes I'm surprised. This one should work because they don't have any arguments, and we'll get to test that our precedence works out properly, I believe. So let's just run that test as well. It might work for free. Boom. Let's add that to our index in case I screw something up. Okay, so let's run this one. This one is definitely going to fail because we don't know what to do with this. We're expecting a right paren, but we're going to get an integer, and we should get a helpful error saying unexpected integer. Unexpected integer. There it is. Parse method calls with parens. Unexpected integer. But we can work on that. Call expression. So let's refactor this a little bit. Node equals that. Return node. And let's just put this at the top, and let's put this at the bottom. And in between here, we're going to consume some arguments. I'm going to say, oh, that actually comes down here. So if it's an r-paren, then let's just advance. Okay, no, let's do it this way. If it's not an r-paren, then we're going to consume the arguments. I'm not sure what to do with this yet, so let's just put that over there. So if it's not an r-paren, then we're going to assume there's some arguments. And I think what we can do is just say auto arg equals parse expression env lowest, and then we have to pass in the locals. And we can say the node, let's just rename this because it's a little bit confusing. Call node, add arg. And I believe we want to keep going while the current token is a comma. We want to keep doing that. We want to do it over and over again. And we do need to advance past the comma. So I think this is a kind of a pattern we'll use for the array and hash stuff as well. So where if you see an expression that's not the closing brace or paren or whatever, you're going to consume it. You're going to parse it as an expression and then add it to your vector. And then while you have a comma in between, you're going to keep doing that in a loop. And we're going to keep running that. And then I think we need to make sure that we do this again, maybe. This I'm not super clear on. I just need to think through this a little bit. So if there are no arguments, then this whole branch is skipped, and we verify that there's a right paren. If there is no right paren, then we assume that there's arguments. Yeah, I think there's a bug here with like if you do an open paren, like if you have just foo that, and then this is the end of the file. There's literally nothing left. I think this is going to break, but since I don't have a test for that, I'm just going to leave it. I'm going to leave it for now and come back to that. But let's do this. To do test for unclose parens at end of file. We'll leave a test for that. Okay, well, only one way to find out if I did the right thing is to run our tests. Boom. Okay, let's add that to the index. Okay, so this one's a little more complicated because it has an infix operation as an argument and some new lines. So, you know, if we did everything right, it should just work. It should work for free. And it does. Let's add that to the index. And let's do our little to-do here. So if I just have nothing here, this should raise an error. Syntax error. Don't know what it should say yet, so I'm just going to do that. What does the Ruby version say? This says, but the message was string 1, parse error on value false, end. That's so cryptic. Hopefully ours will look a little bit better than that. I'm hoping ours can be a little more helpful. Yeah, that's actually not bad. So let's say that that's what we wanted to say. Syntax error, unexpected end of input. I'm pretty happy with that, and it didn't break. See, I'm glad we didn't write a bunch of code here to handle that because we got it handled for free by just calling parse expression. We expected an expression, we didn't get it. So this threw the error that we wanted, so I don't need to write code for that. So this is why, boys and girls, you should not write code before you have a test, a failing test to prove that you need it. Okay, so we did it, I think. Did I miss anything? We did method calls with parentheses. Now let's do it without parentheses. Now this is going to be a little more challenging. No, this one should just work because there's no arguments, I think. Because we did that in the last video. If you just have a bare identifier, it's just a method call. Yep. Okay, we'll do that. But this one has arguments, and this one's going to fail, I think. It's going to fail. It's going to fail. Yes. Unexpected integer. And it's like, I don't know what to do with that. Okay, so this is going to be a little bit different technique. Parse expression, get back to this method. Because there's really no operator to go by. I mean, if anything, it would be just space, and our spaces are collapsed. But I think that we can sort of puzzle through this and just treat this as like a special case. Let's go back to here. If I look at this, this is this is the null denotation, meaning there's nothing on the left of it. It just stands by itself. We get through this part of parse expression and we get a null denotation. So if I were to do a printf right here, left would be an identifier. And the current token would be, in our case, it would be an integer. Okay, so if I were to call get precedence on this integer, which is our current token, I would get back lowest. So I think those are the two conditions that we want to look out for. And we want to do it before this while loop. That might work if we did it after the while loop. I don't think it would. So my hunch is that we want to do it right here, right before the while loop. And only in these conditions. If left is an identifier and get precedence is lowest, I think we want to do something special, and we want to treat it like a method call with arguments. So let's just try it. I might be way off, but let's say if left is identifier and get precedence. Oh, it doesn't actually take an argument, but you get the point. And get precedence is lowest. What happens if get precedence, you pass it? Oh, goodness. Parser. What happens if you pass it like an end of line or end of file? It's just always going to return lowest. And let's just check that we're not at the end of a line. So current token is not EOL and current token is not end of file. I think that's all the conditions that we care about. What do you, no member, oh, I think I have to do it this way. Token type identifier. Is that happy type prints? What are you complaining about? Oh, not token type. My bad. No type. Okay, and then these are not pointers. Might be a mistake that I did it that way. Okay. I think that's the conditional that we care about. We want to do something. How about we do parse call expression without parens? Maybe. Left and locals. Okay. Yeah. Without parens. Parse call expression. So let's rename this to with parens. And we'll say this one is without parens. And I know there's a lot of duplication here, but I think we can eliminate that pretty soon. And then go to our parser. We'll say with parens and without, like so. And parse call expression. There's another place that I need to fix with parens. And now this one's without parens. Just make sure that I'm doing this right, because if there's an L paren, it's going to return something higher than lowest, right? So if this current token is a left paren, this if will never be true because it's not going to be lowest. So think that that's how we do this. So now we just get to write this parse call expression without parens. I kind of wish I had written this one first. So let's just go with it. Let's get rid of the advance because we don't want there's no left paren to consume. We build the call node. We definitely don't need this. So if the current token is not end of line, then we're going to consume some args. And this can go away and that can go away. Okay, I think that's the meat of this one. And there's a lot of duplication here. But as soon as my test is green, I'm going to do some refactoring. I want to resist the urge. Resist the urge to refactor while my test is failing. They always say red, green, then refactor. which is a little weird because we don't have colors, but you get the idea. Okay. Call nil foo should be equal to that. So did we not? Oh. We didn't actually do anything with this. We consumed the tokens, but we didn't actually do anything. So I think we need to assign this back to left. Does that fix our test? Boom. Okay, so now we have passing tests. Now I can go do some refactoring. So this is the one without parens. This is the one with parens. Let's do this. Let's say we're going to advance past the paren. We're going to, we'll just return a call node right here. So if we have the right paren right away, so it's just there's no arguments, we'll do this. We'll say return, and there's no arguments. So pretty simple. Don't even need that or that. However, if that guard clause, if this if is false, then we want to do auto call node equals parse call expression without parens, env left and locals. And then I think we can just delete all this code and check that we have a right paren, advance past that token. And now I believe we have some code that is largely deduplicated. So this parse call with parens relies on without parens to do the meat of the parsing. Anyway, in my head, that made sense. We will find out. No, it didn't quite work. Didn't quite work. Yeah, maybe I just put back all the duplication and call it good, because my brain isn't seeing how to make one rely on the other quite yet. We'll just check that out. Okay, so this is the one that works, right? Parser test. Yeah, that's the one that works. I think there's some way to do this, but I don't think this is horrible, so maybe I just leave it. It's a little bit easier to reason about with it separate, even though there's a little bit of duplication here. So, yeah, I'm gonna leave it for now. It's not as pretty as I would like, but who cares? Who cares? Okay, so parser test. Let's just see if this one works. It does, and let's see if this one works. It does. Cool. Well, is there anything else we need to test? I think this is cool right here because this shows that the operator precedence works correctly. Because so if I made a new one here, we want this to be foo1 plus 2. Not, we don't want it to be foo, actually I said that backwards. We don't want it to be this, foo1 plus 2. We want it to be foo1 plus 2 like this. So let's just, I don't know, let's just test that. It won't hurt to add another test. Oh, yeah, you don't like that. That's fine. I'll fix that in a second. So we definitely want the 1 plus 2 to happen first, which is passed to foo. And if our parser does that, then that's great. That means our operator precedence is working as designed. I'll move this one up here. And then because our failures are a little bit different, we'll just put an if here because our message is a little bit different. I don't even care what their message looks like. Just want to be sure that it's, yeah, I do. That way we can have something to look at. So this is what their message looks like. And our message looks a little bit prettier, I think. A little bit easier to read. Cool. Well, that's all of method calls. Okay, let me show you what I've been working on here. A little bit off camera. I added receiver. So you can now call a method on a receiver like foo.bar. And you can pass args. And let's just make sure that foo.bar.baz actually works. Maybe, what should I get? I should get this. Well, look, it's a call to foo, call to bar on that, call to baz on that. So if I did it right, then that will be properly nested. And, oh, that's the wrong test. I thought that looked funny. It is, okay. And let me show you how I did that. This was a little weird, but I created a new parse send expression function that uses the dot operator, and this is a left denotation. So we treat the dot like an operator, and the dot operator. Parser HPP. The dot operator has its own precedence, and I stuck it in here. I did some Googling to see what precedence the dot operator has in Ruby and got some conflicting information, did some experimentation, and I think this is correct. If I find out otherwise, it shouldn't be too hard to move this up or down as needed. But that's the beauty of the Parser algorithm, is that you can just rearrange these to do what you need to do. So parse send expression will build a call node with a actual receiver of the left node. In this case, like a foo identifier, which itself turns into a call. And then the tricky part, took me a minute to figure out, was how to consume args. So I copied this code that we had at the top of parse expression right here. So a little bit of duplication there, but anyway. I don't know how much I need to get into that. Let's just show the diff. Oh, and then I also had to teach these parse call expression functions how to handle incoming nodes. If it gets an identifier, then create a call node. If you already have a call node, then just use that. So it's a little bit convoluted, and there's probably a better way to do this, but I'm happy that it works, and I'm just going to commit this. Parse method calls with a receiver. So let's call it good for this video. I do want to make one more video for if and else if and else, because this is going to be a little bit different. It's going to take kind of a new unique node type that we haven't really tackled before. So I guess there will be at least one more video after this one where we'll do the ifs and then hopefully we'll be able to parse this file, and I will be so happy when that moment comes. So hey, thanks for hanging out with me tonight on this pretty big session of coding and hacking, and I appreciate you always being an encouragement to me and to other developers as we work on our little hobby projects. This is what open source is all about, community and hanging out and encouraging one another. So I appreciate you, and I will see you next time. Bye.